Let's solve this integral.
The indefinite integral of dx over the square root of x squared minus 9 will be solved using trigonometric substitution. The rule for trig sub is when you have x squared minus a squared, you'll substitute your x value as a secant theta. Since our a squared value is 9, our x will be equal to 3 times secant theta, and our dx is the derivative of x, so we'll be left with 3 times secant theta tan theta d theta. Wherever we see a dx or an x in our original integral, we'll go ahead and substitute our new values in terms of theta. So on top, we'll plug in our dx, which is 3 times secant theta times tangent theta d theta. And on the bottom, we'll plug in our x value, our 3 secant theta squared minus 9. A lot of the process of trigonometric substitution is recognizing your trigonometric identities as you go along and rewriting things until you're able to do something with them. For example, here I factored out a 9 to isolate the secant squared theta minus 1, which is the equivalent trigonometric identity of tangent squared theta. Then in the denominator, we're able to take out the 9 from the square root, and we'll be left with 3 in the numerator times secant squared theta tan theta d theta over 3 times the square root of tangent squared theta. Then both of those 3's cancel. As we keep rewriting and simplifying our integral, we'll be able to cancel our tangent theta in the numerator and the tangent theta in the denominator. This will leave us with the integral of secant theta d theta. The solution to this is the natural log of the absolute value of secant theta plus tangent theta plus c. Now we have our solution in terms of theta, but because we started in terms of x, we need to get back into terms of x. And we'll do this by using a right triangle so that we're able to substitute our trig identities in theta using SOHCAHTOA. At the very beginning of solving our integral, we said that x was equal to 3 times secant theta. To isolate one of our trigonometric values to determine where to put what along our right triangle, we'll divide both sides by 3. This will leave us with x over 3 equals secant theta. Since cosine is adjacent over hypotenuse and secant is the reciprocal of cosine, our secant value is hypotenuse over adjacent, so we'll put our x along our hypotenuse and our 3 where our adjacent side is. Now that we have our sides labeled, we'll use SOHCAHTOA and their reciprocals to rewrite our solution in terms of x. This will leave us with the final answer of the natural log of the absolute value of x plus the square root of x squared minus 9 plus c.